You don't need an expensive tool to test continuity, just this classic chip. Hey guys, in this video I'll show you how to make a continuity tester with a 555 timer and a few components. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 4 alligator clips, 10 jumper wires, 2 10 nanofarad ceramic capacitor, 1 10 kilo ohm resistor, 1 33 kilo ohm resistor, 1 1 kilo ohm resistor, 1 39 ohm resistor, a 9 volt battery buckle connector, a 9 volt battery, a 5 watt speaker, 1 BC 547 NPN transistor, 1 BC 557 PNP transistor, 1 555 timer IC, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2 is trigger. It is used to start the timing interval in both monostable and astable modes. Pin 3 is output. It delivers the result of the timer's operation based on its mode, either monostable, astable, or bistable. Pin 4 is reset. It is used to reset the 555 timer's internal flip-flop. Pin 5 is control. It allows you to control the threshold voltage levels that the internal comparators use to set and reset the flip-flop. Pin 6 is threshold. It monitors the voltage of the capacitor connected to the circuit. Pin 7 is discharge. It controls the charge and discharge cycle of the timing capacitor. Pin 8 is VCC. It is responsible for supplying the power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer IC on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Use a jumper wire to connect pin 4 or reset to pin 8 or VCC. A jumper wire connects pin 1 or ground to the negative rail. Insert the emitter of a BC557 PNP transistor into the same row as pin 8 of the 555. Insert a jumper wire into the same row as the collector of the BC557 and the positive rail. Bend the ends of a 10 kilo ohm resistor. Insert a 10 kilo ohm resistor into the base of the BC557 and the left side of the breadboard. Insert a 10 nanofarad ceramic capacitor into pin 2 or trigger in the negative rail. Bend the ends of a 33 kilo ohm resistor. Insert a 33 kilo ohm resistor into pin 3 or output in pin 6 or threshold. Insert a jumper wire into pin 5 or control on the left side of the breadboard. Insert a 10 nanofarad ceramic capacitor into the same row as the jumper wire and the negative rail. Bend the ends of a 1 kilo ohm resistor. Insert a 1 kilo ohm resistor into pin 3 or output in several rows below the 555. Insert the base of a BC547 NPN transistor into the same row as the resistor. Insert a jumper wire into the emitter of the BC547 and the negative rail. Bend the ends of a 39 ohm resistor. Insert a 39 ohm resistor into the positive rail and a few columns to the left of the breadboard. Insert a jumper wire into the same row as the collector of the BC547. Attach an alligator clip to the other end of the jumper wire. Insert a jumper wire into the same row as the 39 ohm resistor. Attach an alligator clip to the other end of the jumper wire. Attach the other end of the jumper wires to the 5-watt speaker. Insert a jumper wire into the negative rail. Attach an alligator clip to the other end of the jumper wire. Insert a jumper wire into the same row as the 10 kilo ohm resistor. Attach an alligator clip to the other end of the jumper wire. Connect the 9-volt battery buckle connector to the 9-volt battery. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. Before doing any tests, we should first confirm that the continuity tester itself is working correctly. To check this, simply touch the two probes together. We hear a beep, so it confirms there is continuity and that the probes and circuit are functioning properly. Let's test the continuity of this jumper wire. Attach the jumper wire to the alligator clips. We hear a beep, so there is continuity. We can also check continuity by touching the alligator clip tips directly to the jumper wire. Let's dive into the circuit and break it down step by step. This circuit is a 555 timer-based continuity tester that produces a clear audible tone whenever the two probes are electrically connected through a low-resistance path. Power comes from a 9-volt battery. The BC557 PNP transistor at the top acts as a high-side power switch for the 555 timer. Its collector is connected to the positive supply and its emitter feeds VCC and reset of the 555. The base of the BC557 is fed through R1 and controlled by the probe circuit. When the probes are open, the BC557 is off, so the 555 receives no power and the circuit stays silent. This keeps current consumption extremely low when the tester is idle. The probes are the key sensing element. One probe is tied to ground and the other feeds the base network of the BC557 through R1. When the probes touch each other or conductive path, a small current flows, pulling the BC557 base low relative to its emitter. This forward biases the PNP transistor, turning it on and supplying power to the 555. Once powered, the 555 is configured as a stable multi-vibrator. Pin 2 and Pin 6 are tied together and connected to timing capacitor C1. As C1 charges and discharges through R2, the voltage at Pin 2 and Pin 6 repeatedly crosses the internal 1/3 VCC and 2/3 VCC thresholds of the 555. When the voltage drops below about 1/3 of VCC, the output at Pin 3 goes high. When it rises above about 2/3 of VCC, the output flips low and the internal discharge transistor briefly discharges C1. This cycle repeats continuously, producing a square wave signal in the audio range. The value of R2 and C1 sets the pitch of the tone you hear. Pin 5 is bypassed to ground with C2, which stabilizes the internal reference voltages of the 555 and prevents false triggering or jitter, especially important in a sensitive probe-based circuit. Pin 1 is grounded, completing the IC's power connections. The output from Pin 3 of the 555 is not sent directly to the speaker. Instead, it drives the base of an NPN transistor BC547 through R3. This transistor acts as a current amplifier, allowing the low-power 555 output to control a much higher current suitable for driving a speaker. When the 555 output goes high, the BC547 turns on and sinks current through the speaker. The speaker itself is connected to the positive rail through R4. This resistor limits the current through the 5-watt speaker, protecting both the speaker and the BC547 from excessive current. As the BC547 switches on and off at the oscillator frequency, current pulses flow through the speaker coil, producing a strong audible tone whenever continuity is detected. In normal use, when the probes are not connected, the BC557 remains off, the 555 is unpowered, and the circuit draws almost no current. The moment continuity exists between the probes, the BC557 powers the 555, the oscillator starts, the BC547 amplifies the signal, and the speaker sounds. I hope this video has shown you how to make a continuity tester with a 555 timer IC. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Just click the link in the description to download your copy now. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.